Okay, so example 2. I was curious about the demographics of the passengers and crew of the Titanic. Those who perished, those who survived, and those who occupied the lifeboats. How gravely was the tragedy enhanced by class distinction and prejudice? Okay, how you're going to see this worded. You will be asked, is there a relationship between class and survival? Or is there an association? That's how normally this would be asked. Here's how we know that this is a chi-square test. We are looking at categorical data. Then we have two variables. Those variables are class and survival. Both of those tell us that this is a chi-square test for independence or association. Like I said, either of those terms can be used. So that is the thought process that you should be going through. I will tell you that is one of my concerns with the AP test, is the AP test you're just going to be given a hypothesis test, and you're going to have to determine which of all the types it is. So that's the thought process for this one. Okay. Here's the first thing you're going to love about this test. There is no P. There's no parameter. We can just skip that right away. We start right at H. The way this test is structured, you are always going to assume that there is no relationship between the two variables. So my null, I'm going to assume that class and survival are independent. Instead of saying the word independent, you might see the term not associated. I don't care which one you use. Pick one though, don't use both. So then our alternative, what we're looking for evidence for, is that class and survival are dependent. And when I say independent and dependent, I'm referring to independent and dependent from probability. So independent would mean if I told you someone's class, it doesn't give you any extra information as to the likelihood that that person died or survived. So again, if class and survival are independent, if I were to tell you somebody's class, it would not change the probability that that person died or survived. That is always how you're going to structure your null. You're going to assume that the two variables are independent. You are going to look for evidence otherwise. Assumptions. Exactly the same as they were before. So we want to know, is this a random sample? I didn't tell you that, so we're going to say unsure. Proceed with caution. Second assumption, we talked about this. Is it a large sample? In order for it to be large, all of the expected values have to be at least 5. My expectation for this, I want you to show the formula. So it's row total times column total divided by grand total. Generally, what I do for the expected values, because we were given a table initially, I organize my expected values in the same kind of table. You do not need to show work for every expected value. Show work for one or two of them. So I'm going to show work for this first cell. That would be this one. So the row total is 885. The column total is 1490. And I divide by the grand total, which is 2,201. And that is about 599.11. Okay, so then this one here, the one next to it, the row total is still 885. The column total is 711. And the grand total is 2,201. And that ends up being about 285.89. Okay, from there, just calculate the rest of them and put them in the table. I'll do them real quick if you just stay with me. So those are all of the expected values. So then we need to confirm all of them are in fact greater than or equal to 5. Okay. You with me? If I do n, this is an upper-tailed chi-square test for independence. Alpha is 0.05. Here's how you figure out degrees of freedom. You take the number of columns and you subtract 1, and you multiply by the number of rows minus 1. So in our case, we get 2 minus 1 times 4 minus 1. So we have 3 degrees of freedom. I don't care that you show the formula. Also, pro tip, the calculator will give you degrees of freedom. So once you do the chi-square test on your calculator, you can go back and fill in the degrees of freedom if you want. Test statistic. So we're going to put our formula. Remember, like I said, the nice thing about chi-square is every single chi-square test always has the same formula. Can somebody tell me what the very first observed value in the table was? Like, can you look back, please?
673.
Thank you. So 673 minus 599 squared over 599 plus dot, dot, dot. Can somebody tell me the last one in the table? Bottom right.
178.
Thank you. 178 subtract 228 squared over 228. Okay. Since I already showed you how to do this in the calculator, I want you to finish this part of the problem. So I want you to find the test statistic, the p-value, and draw a figure. Remember, you're going to have to put your observed in one matrix, your expected in a different matrix. So take 2 or 3 minutes to do that now, please. Okay, so here's what you should have gotten. Any questions? Are we okay if I keep going then? Yeah. Ooh. And if you noticed, when you did this, your calculator gave you degrees of freedom. So if you can't remember the degrees of freedom formula, just wait until you carry out the test and then write down the degrees of freedom. Okay. So 0 is less than 0.05. So we are going to reject the null. So, lastly, our two sentences based on my analysis. I reject the null and instead believe that class and survival are dependent. Class and survival are dependent. So then our p-value, 0 is the probability of obtaining the observed distribution or, more extreme, assuming that class and survival are independent. So again, there's a few different words you're going to look out for to know to do this test. You might see independence, you might see associated, you might see is there a relationship. Any of those terms should tell you it's a chi-square test for independence. This test is not that bad, right? You don't have to do the p step. The figure isn't bad. We do have one other thing to look at real quick, but before we do that, are there any questions here? Okay, so oftentimes what happens with a test like this is the next logical question is where was the biggest difference? Where was the biggest difference between what was expected and what was observed? And so on the next page, there is some output for us to look at. So if you can see at the top, it'll tell you exactly what this displays. The expected counts are printed below the observed counts. And then below that are the chi-square contributions. What that means is this number here is the chi-square value for that cell. For that cell. And so what you would do if you're carrying out this test is you're going to find the biggest chi-square value. This chi-square value is huge. It's huge. And if we look at the numbers, here's what it's telling us. These are, I believe, the second class passengers. First class. Okay, which makes more sense. This is the crew, this is first class, this is second class, and this is third class. So what this is telling us is that 203 first class passengers survived, but we only expected 105 to. So significantly more first class passengers survived than should have if there were no relationship between survival and class. And that should make sense. On the Titanic, you would expect that first class are going to be the ones that survive. You would not have to come up with this yourself, but you would need to know how to read it. And then notice at the bottom, you are given all the information from the test. You're given the chi-square value, degrees of freedom, and the p-value. So it does occasionally happen on the AP test where you are just given this output and then asked to make a conclusion. So you would need to be able to read it. Questions for me? Ela?
What are the three categories on like that? Or for the crew, what's the first, middle, and bottom line?
Observed, expected, then the chi-square value for just that cell.
Okay.
Anything else?
Do we ever use like that chi-square value for just that cell, or is it?
This is the only time you ever would.
Okay.
Okay, one AP problem for us to do. It is not the next page. You're going to skip that one. You are going to go to this page instead. It says a rural county hospital offers several health services. Did you find it? You see it? Great, thank you for the three people that nodded their heads at me. Okay, I have a few things I want to tell you before you get started. First, let's read the question. Using a significance level of 0.05, conduct an appropriate test to determine if, for adult residents of this county, there is an association between gender and whether or not they were satisfied. So association, exactly the same as dependence. So association means there's some type of relationship between the two variables. In this case, it's important to note that our two variables are both categorical. Gender, whether or not they were satisfied. Okay. If we were to talk about the test that we just did, what is the part of the test that required the most effort, would you argue? The expected values?
Yeah.
You guys agree with me?
Yes.
Okay, ready? I'm about to make your life even easier. The calculator will calculate the expected values for you. So here's what I want you to do right now. Go into your calculator. In matrix A, put these four numbers in. So in your calculator, go to matrix A, put those four numbers in, please. Because, of course, we don't care about the totals. Got them in there? Okay, so what I'm arguing is that we don't need to do anything with matrix B. Your matrix B is currently the expected values from the past problem, right? A 4x2 matrix. What I want you to do right now is do the chi-square test. So don't do anything with matrix B. Go to stat, go over to tests, go down and choose your chi-square test. And it should come up observed in matrix A and then expected in matrix B. And carry out your test. You should get a chi-square value of 4.12. Do you?
Yep.
What I want you to do now, go back and look at matrix B. It should now be 2x2. Those are the expected values.
How do you do this expected?
Okay. Hey, are you all with me? Okay, can I tell you practically how I want you to use this? Or my suggestion for you? I would suggest you do not calculate the expected values by hand. There's no reason to do that. What I would do is carry out the test, leave yourself some room in that assumption, do the rest of the test, and then go back and write those expected values. You do need to show work for one of them. So show work like we did, but don't calculate them all by hand because the calculator is going to do it anyway. Sound good? Okay, you have this test to do then, please. If you have any questions, let me know. Okay, let's go over this. Here is the AP rubric. For the null, we are assuming that gender and satisfaction with the services are independent or not associated. Like I said, don't write both. Pick one or the other. And then we're looking for evidence that gender and satisfaction are dependent, that there is a relationship between the two. First condition or first assumption, random sample was taken. Second one is all the expecteds have had to be at least 5. There are your 4 expected values. Like I said, what I would have done is just left myself space, and once I carried out the test on the calculator, went back and filled them in. Did you show work for at least one of them? Okay. Great. You should have a figure. They didn't put a figure. Chi-square value should have been 4.117, p-value of 0.042. You need to make sure that you showed that that was less than 0.05, so we reject the null. And we do believe that there is an association or a relationship between gender and satisfaction, or that they are dependent. Hila?
I have 2 questions.
Yes.
One, I thought you said that we weren't supposed to say that we, like, in the conclusion that we believe or we don't believe the null or the alternative.
You can believe the alternative, but not the null. So we can never say that we believe the null, but the alternative we can.
Okay, and then the second thing was, are we gonna have to draw like the figure on the AP test? So then why don't they have it in the rubric?
Because I require you to do it, but technically they don't.
Okay.
I ask you to do it though because it is considered showing work.
Okay.
Part B, is that a reasonable estimate?
And on part for when, because.
Did we get to part B?
Oh, there is a part B. I didn't
we
even
didn't
know there was a
realize.
part B.
Okay. Read part B right now and take a minute and come up with an answer. Any idea for part B? What's our gut feeling? Yes, it's reasonable, no, it's not.
Not reasonable.
No.
Okay. That was not a good gut feeling. You should have said yes because this is a random sample. That was it. Random sample.